So to develop all the values you need to memorize with the unit circle, we're first going to break it up into different families, different groups that are easy to figure out on their own and that are connected to each other. And one of the big ideas from our unit circle is that coordinates on your unit circle are always cos theta comma sine theta. So if we know certain coordinates, if we know important points, and we can label their coordinates, we can now do some trigonometry without our calculator. And the axes family on the unit circle are really easy to write the coordinates because your radius is 1. So if I went 1 to the right, does it make sense that my x coordinate is 1 and my y coordinate is 0? If I went up 1, my x coordinate would still be 0, but my y coordinate would be 1. If I went to the left 1, and if I went down 1, so my coordinates are really easy to label for my axis family. My angles are really easy to label. And I'm going to start by doing degrees really close in the middle. So this line would be 0 degrees. Standard position would be degrees. This would be 90 degrees. Halfway around would be 180 degrees. 3/4 would be 270 degrees. And I guess 0 is coterminal with, so I'll write 360 degrees as well. And you could keep going. Right? You could add 90 more to that, and 90 is coterminal with 450. But we're just going to write once around the circle. And so just with this simple math and the big idea, you could now tell me what cos of 180 degrees is. You'd be like, well, 180 degrees is here. That goes with this point, -1, 0. My big idea says, which coordinate is cos? Is my x coordinate cos? Or is my y coordinate cos?
X.
My x coordinate is cos, so cos of 180 degrees is equal to -1. If you put your calculator in degrees and do cos of 180 right now and push enter, you will get -1. And since we've been able to switch between radians and degrees, and you know that 0 radians is exactly 0 degrees, and you know that all the way around is 2 pi radians, halfway around is pi radians. Half of pi, pi divided by 2, would be the same as 90 degrees. And if this is pi over 2, does it make sense if you count by pi over 2s? 1 pi over 2, 2 pi over 2. This will be 3 pi over 2s. At 270 degrees. So now you can do mathematics with radians in your head. If I said, what is sine of 3 pi over 2? You'd look on your unit circle and say sine is connected to the coordinate. At 3 pi over 2, my coordinate is 0, -1. Which coordinate is sine, the x coordinate or the y coordinate? So according to the big idea, the y coordinate is sine. So I can now say that sine of 3 pi over 2 is equal to -1. And if you go to your calculator, and your calculator's in radians, and you type sine of 3 pi over 2, you will get -1. And finally, in black, tangent is sine theta over cos theta. So tangent of theta will always be, and I'll write it in radians here, so tan of 0 will be your y coordinate divided by your x coordinate. So tangent of 0 would be 0 over 1, which is just 0. Tangent of pi, or tangent of 180, will be 0 over -1, will also be 0. But when I go up here to tangent of pi over 2, so for tan of pi over 2, well now, it's sine over cos, which would be 1 over 0. If I write that out, 1 over 0, I have a problem. I have a problem because are you allowed to divide by 0? No. I have a picture of someone who tried to do it, and their whole house imploded over here on the wall. like it's bad. Don't try this at home. So what we write is it's not possible or undefined. And the same thing here at 3 pi over 2, that 0 would be on the bottom. You'd have negative 1 over 0, so that means that it is undefined there as well. Four points, sine, cosine, tan, 3 trig ratios. You just, with this picture, you can now do 12 calculations, mental math, without a calculator. Technically, you can double that because you now can also do secant, cosecant, and cotangent of all those. So with those 4 points give you the opportunity to do 24 mental math calculations where you don't need your calculator. We're going to do that for another 4 points 3 more times, so that's 16 points. That's like 96 mental math calculations you will be able to do and be expected to do without your calculator. Plus anything that's coterminal. So that makes it infinite. We have an infinite amount of things we can now do without our calculator. Family number 2, the pi over 4 family. So the pi over 4 or 45 degree family, and this time we'll start with degrees because that's what's easiest for our brain, says if that angle is 45 degrees in quadrant 1, that means the reference angle for all of the other ones has to be 45 degrees. So in quadrant 2, if you did 180 minus 45, you would get 135 degrees. In quadrant 3, if you did 180 plus 45, you would get 225 degrees. And in quadrant 4, if you did 360 minus a reference angle of 45 degrees, you would get 315 degrees. Now we have to do this same idea in radians. So pi over 4 is equal to 45 degrees. In quadrant 2, if in degrees you would do 180 minus 45 degrees, does it make sense, and I'll just do it off to the side here, that in radians you would do pi minus pi over 4. And you have to be really good at adding and subtracting your fractions. To add or subtract fractions, you need a common denominator. So I'm going to need to change my pi. Does it make sense that I'll change my pi to 4 pi over 4? Minus 1 pi over 4. And this will be 3 pi over 4. In quadrant 3, you would do pi plus your reference angle. So I just change that to a plus sign. And I get...
Sorry for the interruption. Anyone who was scheduled for the 9:30 bus ridership is now arrived. So that's 9:30 teachers. Mr. Roberts, Mr. Rogaway, and Mr. Desirano, you can now go onto the bus, and then you can all just continue with the schedule after that. Thank you.
8 pi over 4 minus pi over 4 will be 7 pi over 4 for this one. So we can label our radians and our degrees quite easily just knowing about reference angles. Next, we need to find the coordinates. So that means there has to be a way that we can figure this out without a calculator. Trigonometry, sine, cosine, and tangent are based on triangles. So what we're going to do is, and you can put this somewhere on your paper here, is a special triangle, and I'll do it in degrees, because you guys can think better in degrees still. I draw a right angle triangle, and I make one of the angles 45 degrees. Since you know angles in a triangle add up to 180, you would know that the other angle is also 45 degrees. And now, this is a special kind of right angle triangle. If you know two angles are the same, there's a name for that kind of triangle. Does anybody remember the name of it? Whew. It starts with I, rhymes with isosceles. Yes, amazing. You guys are great. And if it's an isosceles triangle, not only are the two angles the same, but we also know that these two sides have to be the same. And here is the power of trigonometry. The power of trigonometry is that it doesn't matter how big or how small the triangle is. If you have 45 degrees, the opposite over adjacent, the opposite over hypotenuse, the adjacent over hypotenuse, all three trig ratios are going to equal no matter how big or how small the triangle is. That means I can just arbitrarily pick a number for here. I'm going to pick 1, just because I don't want to do, if I pick 273, oh my goodness, the a squared plus b squared equals c squared would be horrendous. But it would still work. So if I pick that side as 1, then this side is 1, and a squared plus b squared equals c squared lets me figure out that this is the square root of 2. And from that, I can now write that sine of 45 degrees opposite over hypotenuse is equal to 1 over root 2, which I'm going to write it in rationalized form. Go back to grade 11. Remember, you had to rationalize the denominator to get root 2 over 2. And cos of 45 degrees, adjacent over hypotenuse, also 1 over root 2. I'm going to write that as root 2 over 2. When you're asked for sine of 45 degrees, you can either tell me 1 over root 2 or root 2 over 2. And tan of 45 degrees, opposite over adjacent, 1 over 1, is just 1. Now, had I picked 273, which I'm not going to do right now, but that would make the other side 273. At least for tan, can you see if you wrote 273 over 273, you would still get 1. It will work whichever values you pick. So the special triangle, just knowing it's isosceles, lets you pick numbers that you want. I chose 1. 2 wouldn't be bad. You will always get the same thing. That means on our unit circle, we can now label this point. And then our cast rule and just sort of knowledge about the unit circle makes it obvious what all the other points are. Because if you have the same reference angle, the values in all of these are going to be root 2 over root 2 over 2. But some of them are going to be positive, some of them are going to be negative. Does it make sense that if I go into quadrant 2, my x value will all of a sudden become negative because I'm going to the left, but my y value is still positive? And in quadrant 3, my x value would be negative and my y value would be negative. And in quadrant 4, my x value would be positive, but my y value would be negative. Do you see that that follows the cast rule as well? Your big idea says that your x coordinate is cos and your y coordinate is sine. According to your cast rule, cos is negative in quadrant 2, sine is positive in quadrant 2. And finally, I'll just quickly write them down. Tan of pi over 4 is 1, and you can, same thing, use your cast rule to write all of these down.